Welcome to Almost Here, Round the Corner Future Technology podcast with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more.
Hello, this is Richard Jacobs with the Future Tech Podcast. My guest is Charles H. Martin, PhD. He's a chief scientist at Calculation Consulting. We'll be talking about the machine learning and AI expert work that they do. So, Charles, thanks for coming.
Thanks for having me.
Yeah, so tell me, a little bit more specifically, what's the premise of your company and what do you guys do?
Gotcha. Well, we're specialists in AI and machine learning. We're a boutique consultancy. And what we specialize in is translating research into products. So, sometimes PhDs get a negative rap because they think all these guys do is research, in the academic world. But, what we do, what I've been doing for at least 15 years or more in Silicon Valley, is taking state-of-the-art research in machine learning and AI and translating it into products for companies. So these have included companies like eBay, BlackRock, Google, these kinds of things.
So what's, because you're on the inside, what are some examples of AI that's being used out there that people may not even be aware of, but that you're like super impressed with and maybe you've even worked on?
Well, I think one of the really useful things we do is semantic search and matching. And this is a technology that I think a lot of people need, and they just don't really have access to it. If you buy a product off the shelf, you're going to get you're going to get something in terms of your search product, which is, maybe what was state of the art 10, 15 years ago. The kind of stuff when I was a subject matter expert in machine learning at eBay that we were looking at 10 years ago. And the kind of things you can do today are really new. You can really leverage the natural language processing research coming out of places like Google and OpenAI and build some very sophisticated natural language processing tools for doing semantic search and matching. A good example is Google recently announced a technology called TensorHub, and I had a client that needed us to build a sentence similarity matching service. They were doing something and need to know when one query they were implementing is similar to something else. And I was able to put a prototype together in just a couple days that was production quality. So I think the technology is pretty astounding.
It seems like AI was sleeping for a long time, and all of a sudden the past 2 years, it's woken up and it's advancing quick. Why do you think that's happened, and what made it happen?
So I worked on AI in the 90s, and there were a number of products like hot field nets, associative memories, and things like convolutional nets for simple OCR. And there were products like this in production, but they were very niche and really only accessible to very, very large companies that were doing very specialized things. And then sort of AI research sort of died. Basically funding dried up is what happened. The Cold War ended. I was in a theoretical physics group. And they said, look, funding is ending. We're not really making a lot of progress here. We're going to and we went through this AI winter. And then about 10 years ago, the system called Kaggle was announced, and researchers in Toronto started, guys who were doing AI started submitting their AI projects to Kaggle, and they were competing in AI research, and this stuff started to find out it really worked. And it turns out that there were a small group of researchers who had continued to pursue AI research from the early 90s. They'd spent, the last 10, 15 years working on it, made a lot of progress. And then Google came in and acquired a company, well, actually, I should say Peter Thiel and Elon Musk made some investments in a company called DeepMind, and they have just made tremendous advances in terms of taking what was academic research and turning into production quality tools that people can use. So I think in the past, 5 years or so, Google, Facebook, Amazon, they've put thousands of engineers on this projects to develop and they have developed these open source tools and made them widely available to the business community. So now engineers and developers can develop products very, very quickly. Things that were, something that would take 6 or 8 weeks to do 10 years ago, I could do in a couple days. And something that would take 3 months to do now would have been like, a 5-year research project 5 years ago.
Oh, wow. So TensorFlow, TensorHub or TensorFlow is a product from Google that allows people to use their existing neural networks and other stuff to run simulations. Any other resources? And then I want to ask you about the data side. The neural networks or the AI engines are great, but if you don't have data, then what do you do? So I'm sure there's data repositories now too, right?
I think a lot of people think about AI as if I'm going to build a model and I'm going to train this model and I'm going to put it in production. And they think of it like that's how a lot of people sell it. There are a lot of other things you can do with AI that don't really require that level of sophistication. For example, there are now a lot of technologies, a lot of neural networks in particular, both in TensorFlow, Facebook's product PyTorch, that have been pre-trained. Okay. So if I want to build a system, say, to count the number of cars on a road, I could go to Amazon, I could use the Amazon recognition APIs, I could just use an API, or I could get a version of one of these pre-trained visual recognition systems, download it, and then I could either use it right off the shelf or I could fine-tune it to my data set. So that's the approach we take. We're not trying to design giant neural networks that would require $50,000 of GPU time to train. What we do is we take existing neural networks that have already been pre-trained and either use them out of the box or we fine-tune them on the customer data. And that's really the key to making this stuff work in production. And I think for the past 3 or 4 years or so, this has become very popular in object recognition. So I have, for example, a friend of mine, we're helping him put together a company. They want to do OCR on license plates of cars. So he's got 50,000 images of license plates of cars. And what we want to do is take one of these existing off-the-shelf tools and just tune it a little bit so it works on his data set. Now, within the past 6 months, literally the past 6 months, it's starting to become possible to do this with natural language processing. So there's TensorFlow, there's Google's tools, there's the OpenAI project, there's the Allen Institute for NLP. Many of these are the three big ones that have released. And fourth, right of course, I'm looking right out the window at them here in San Francisco. There's Fast AI over at University of San Francisco. And these groups have produced open source tools for natural language processing that I think you could build very, very sophisticated tools. And again, this is stuff that 6 months ago would have been thought to have been possible. So there's really a lot of advances. And so I would really say with clients, we don't recommend building neural networks from scratch unless they're very small and you're just trying to do some small thing. What we recommend doing is taking one of these off-the-shelf components and fine-tuning them. And the key is knowing how to run them in production. How do you run you want to get this thing to run on, you have, say, 1 million queries coming in every day to your system. Or, you need to get this thing to run in performance at load in a production environment. And making that work is a bit of a challenge if you don't know what the existing tools look like and how to assemble all that. So that's where we really specialize in.
What if, I can see with natural language processing, the data set already is kind of enormous. What if, let's say, could I use a facial recognition database of faces and, I could distinguish the nose from the ear? Could I take that data and then use it to train artificial neural network that was similar, where I wanted to measure, like shoulder width or something, or hip width? Can you do stuff like that with the existing libraries out there?
It's kind of like that, right? So what you might want to do is, you might have, maybe you're trying to detect a certain kind of brand of car, a certain type of, something very specific, like this, something about like what exactly is the brand, or you're trying to determine whether there's some damage on the car, whether there's, something like this. And, what you want to do is you want to take an existing database of images of cars, and then you want to fine tune it on the specific thing you're looking for within that context. The key to getting this to work is really understanding what the existing systems can do and how different your data is. And this is really the key to really having really having familiarity with what the different object detection systems can do. There's object classification, there's object segmentation. Here's an example. I saw this today. Someone is trying to classify rooftops. So they want to count like the amount of rooftops in a city for whatever reason. I can't remember what they have. Rooftops. And so, that's what you have is, it's an object segmentation problem. You have an image coming from a satellite. You want to compute the rooftop. Well, you don't really need it to be very high resolution. You just need to know this is a roof or it's not a roof. And so that's kind of like a very crude level problem. And so you can do that. You can detect this is a building, here's the roof. and then you can get to capture the roof. We actually, I can give you an example of why that might be interesting. We had a client come to us who's a construction company, and they wanted to do things like figure out how much pavement do you need for parking lots. And this is like civil engineering. So you imagine if you had a large amount of, if you had a large number of satellite images, you could figure out, how much is there actually road, where is there a parking lot, how big is the parking lot versus where the building is. And this can all be done automatically. So if you have to analyze, in a large city, in this case, they were doing something like hurricane reconstruction. So they wanted to look across large paths of images and just try to figure out what's there. And I think that's a good example of where this technology would be useful because, you're trying to do something that's fairly low resolution, pretty simple, but right now you're doing it by hand with people, and it's very expensive. So that's a good example.
So just for an example, what would be involved in doing something like that? You'd want to do what, I guess, is it called edge detection or object recognition? Like what are the, some of the things that would be involved in that? We
work in 3 phases. So the first phase we do with any client is a scoping phase. So we try to figure out, is the project viable? So you have to look at what is the problem you're trying to solve and what has been done before, which is similar to it. And then you have to figure out, can I use the existing neural networks, pre-trained neural networks, to make progress in this problem? So in this case, for example, I'll give you an example that's flushed out. And one of the examples we're looking at was doing, they wanted to look at telephone poles. So the telephone pole example is actually where it started. So they wanted to go, can we recognize telephone poles from images? Because what would happen is the hurricane would come to Florida, it would knock down all the telephone poles, and they wanted to know, does this telephone pole have a transformer or not have a transformer? And I said, we were on the call. This is literally how it went. I was on the call with the client for about 2 hours, and why don't we just do it right now? Load up Google's open source image recognition system. Let's go on the internet and get some pictures of telephone poles. Let's put them in to Google's system, and let's see if Google can figure out if there's a transformer or there's not a transformer on this telephone pole. And so I just walked them, through it on the call. Let's just build the prototype right now. So we built the prototype. 2 hours after the call's over, they had existing prototypes. They took it to senior management, and the project was funded.
That's amazing.
You want to. So a lot of times in the industry, people spend a lot of time planning and having a lot of meetings, and it's trying to. You've got to just get your feet wet. You got to jump in the water. You want to know how to swim? You got to jump in the water. So you've got to figure out, here's my data. Here are the existing tools that exist right now. Get those tools up and running. Put your data into them and see what it can do. And you have to get an idea. Look, you have to do it. In physics, we call this the back of the envelope calculation. In physics, when I work on the atom bomb, I worked at the Fermi Institute, where the bomb was invented. A very famous story. Enrico Fermi, the super genius who invented the atom bomb. He would be able to solve a problem by just getting the back of an envelope. He would say, literally, had all these envelopes that they would send messages to each other in the institute. Before email, they had these large manila envelopes, and he was famous for being able to solve any problem in the back of an envelope. They actually, when you go to take physics in school, they have a class called back of the envelope calculations. You learn how to solve problems quickly, how to get a quick estimate of a problem. So your goal in any AI project is to estimate as quickly as possible whether it's viable or not. And so you have to do this in the case with edge detection. Yeah, it'd be the same thing. You'd want to get some images, put it into the existing edge detector, and just figure out, is this thing even viable? Does it make sense or does it not make sense? So the example is we had a case where then after we did this project, they then wanted to do everything using LiDAR data. I said, no. LiDAR data is not images. What works for images does not work for LiDAR data. And they do not exist. So you have to understand the way, sometimes the way people think in business, well, why can't you do it on, this is an image, that's an image, what's the difference? They go, no, it's completely different. This is an extremely technical field. So you can't come to me and say, oh, we built a prototype using images from cameras, and now we want to put into production a system that uses LiDAR data images. But, when you work in industry, people ask you things. They ask you to do things like this, and you're like, oh, boy. So you have to know, you have to sort of flush out what's doable. And so that was something you have to know immediately. Well, you want to do LiDAR. Well, now we've got to figure out, does there exist a LiDAR system that can do object detection? Or maybe you want to do object segmentation. So it's very important to sort of get these basic things flushed out at the beginning. And then you can begin. Then the next phase of this is a research phase. 3 months or so, you have to research whether what you want to do, can you actually build a working prototype? And that is something that a lot of clients, a lot of customers in the space really are not prepared for. A lot of businesses, when they think about doing innovation, they think about bringing on a pilot. I want to take this technology. I have a pilot that some startup has built. I want to pilot this technology in my existing company and see what it does. That's how a lot of companies think about innovation. Well, we do, of course, we can do that for you. But what I'm talking about from going from research to development means we're going to build the pilot. We're going to construct the pilot internally. And that means you have to take some risk. You're going to have to decide, okay, I need to try to take the existing algorithms and retrain some neural network or fine tune it and try to get it working on our existing system so that it will, in the next phase, it will become the product that we release. And that's really the key to realizing that research phase that you have to go through, the pre-product phase, where you go from research to development. That research phase might take anywhere from 3 months to 18 months, depending on, how complex it is, what you're trying to do, what the marketplace is for what you're doing. If you're trying to solve a problem that's going to make $20 or $30 million in revenue, spending 6 to 8 weeks on it probably isn't enough. You need to figure out how. No, but a lot of big companies have a problem with this because if you think about how people are. Go ahead.
Yeah, I have a question.
Sure.
For small projects, I've gone to Google and tried to use TensorFlow and some of these other things, and maybe the result wasn't great. But in this environment where things are changing so fast, if I wait 6 months and I go back, is it pretty likely I'm going to get a much better result because things are changing so fast, or it's not that fast?
What I would say is that, and we advise when we're advising startups, focus on your product line. Focus on product market fit. Because yes, 6 months from now, all the technology you're using could be completely commoditized or disappear. So if you build something now with TensorFlow and you try to build a model and you get something kind of working and you can get it into production and you begin showing that it's useful, chances are 6 months from now, there may be some completely new technology that's much, much better. You're going to pick one neural network and you think you've got this really great neural network. And 6 months from now, someone's going to have a new neural network which has 5, 6, 10% more accuracy. And you don't want to build a business around, I've got this magical neural network that can solve this problem. You should anticipate that it's going to be commoditized. Absolutely.
No, I'm saying if I have a problem that a neural network could solve, and right now if I go to the TensorFlow or wherever and it just doesn't work well enough, let's say I'm trying to use NLP for something, and it's just not working out right now. It sounds like there's a good chance if I just wait a few months and go back, the technology will be so much better that it'll work better for me at that point.
I can give a really specific answer to this, which is a little more subtle. When you build a model for something and you put it in production, that model, when you're in the laboratory and you're building it, it should be able to make predictions about something. And that may not even be a neural network. It may be some simple semantic analysis, latent semantic analysis, or some simple SVM that, sort of was really hard to do 10 years ago. You build a model, you put it in production, and then you measure how well it works. You should be able to correlate how well the model did in tests versus how well it does in the real world. That is, you should be able to solve what we call, in finance, we call this the attribution problem. You should be able to attribute the revenue you generate or the margin you lost or the efficiency you gained by how well the model was predicted to do. Now, maybe you're only going to get a 5% increase in efficiency. But, for some companies, 5% could be a game changer. If you lower your margins by 5%, that's huge. So the key here is that you want to be able to do that. Now, if you can't do that, if you don't have any idea, if you put your model into production and you don't have any idea why it works or whether it's working or it's not working, then you're going to have a really hard time moving on to the next phase. And we have this problem. I have this problem with clients. When I work with their staff, that they build a model, they put it in production, it does something, they tell me it works, they tell me it doesn't work. Well, what did you do in test? Where did it work and where did it fail? And if you make an improvement, can you show that when I make the improvement in the laboratory, can you predict that you're going to see that improvement in production? And if not, why not? And I think that's what you need to do. And it's that level of subtlety that you have to have a really good connection between what's going on in your test environment when you build the model and what's going on in your production environment.
Okay, makes sense.
The-
So this is the
so
consulting that you do, is to help companies use the models that are out there properly and not get false positives or false negatives or think that it doesn't work for them when it actually could.
Right. So what I try to do is help them develop these models, get these models into production, measure how well the model is doing, and then make improvements. Let me give you a really specific example. I had a client who was a computational advertising client, and they had models in production that would predict what people click on. Right? When you're running you run ads on websites, and you want to predict how many views you're going to get, and you want to predict how many clicks you're going to get. So, in the laboratory, maybe I see a 40%. When we did this, we got like a 30% boost in revenue in a month. So it was just skyrocketed. Boom. You put the thing into production, revenue goes up 30%. That pays my fee for the whole year. So then 6 months, then you've got to make improvements. All right. So one of the things they didn't understand is that, well, they were measuring the returns every week. Every week we want to put a model in production, and we want to see how well it does. Okay, that sounds ambitious, but you're not Google. You don't have that much return. So so the problem is that, it's kind of like running a restaurant and saying, well, I'm going to run a new special every week, and I want to see how many times people like the special. But if nobody's coming to your restaurant,
there may not be enough scale in order to get a signal.
That's right. You may, if you're running you may need to run that thing 20 or 30 times. You may need to run it for 5 or 6 weeks, on and off. Every other week you run that particular special, and then over the course of 3 months, whether people like it or not.
So here's an interesting question then. What do you do with companies that just have low volume of whatever it is they're trying to test? How can you piggyback on high volume type results to help low volume businesses?
Well, look, we were able to get a boost in production, a 30% boost in revenue within a month. Working closely with the CTO. We actually wrote all the code in Ruby because their system was written in Ruby. So we wrote it all in Ruby. Again, I built the whole system in Ruby, and then we started, productionalizing it. Right. Once we showed we could get revenue, then we moved everything to Spark. After we did the prototyping, the challenge is knowing, are you actually measuring what you think you're measuring? So in this case, no, it's very hard to take. It's very easy to go from 0 to 1. If you're not doing anything and you've collected the data, we can give you a model that will work pretty well. To go to the next phase takes a lot of work, and you have to be careful in how you design your experiments. And this is the key: is designing good experiments that that are appropriate for the amount of data that you have. You may not be able to leverage a particularly sophisticated model if you don't have enough data to train that model. So you may need to just do something very simple, and you've got to sort of figure out so not every company is ready to run a neural network with 100 million parameters. You may be better off just running a simpler machine learning model, or maybe a very small neural network may be the right solution for you. I'll give you an example of how we showed this, because this was a difficult conversation to have. And so, when you're working with a client, you ask, how can I show the client that doing tests every week is not the right thing to do? Well, here's the solution we came up with. Well, we decided to run the model in production twice. We run a duplicate of the model, the exact same model. We make a copy of it. We put half the traffic to one copy and half the traffic to another copy. So what happens? Well, then you measure how much revenue boost you get on each model, and you look at the fluctuations. And what you find out is that the amount of fluctuation in your data, the number of clicks you get per day, is so different, is more different day to day, or on average, than you would see across the two models. So in other words, maybe you see 100 clicks in one model and 150 clicks in the other model, and it's just you realize. Then they realized, if running the data for 1 week just isn't enough. You're not getting enough good statistics, so you have to run it longer. You can't move that quickly. You need to run and the problem in this case was that, when you're running an advertising company, every month you get new advertisers coming in, and so you're showing new ads every month, and so. You had to use a simpler model and not try to put things into production so quickly, and think more carefully about how you're measuring your results. And that's the reality of how these systems work.
Okay, I got it. So I don't know if you could talk about eBay and you work for them, but can you give a couple more specific examples of how you use machine learning and what did it tell you to do and what the outcomes were? Whatever ones you can talk about.
Sure. I mean, eBay was 10 years ago, so whatever we were doing there is so out of date that I've been doing machine learning and AI in the Valley for over almost 20 years. So we were looking at eBay, the scale at which eBay was at. We were looking at ways to improve the search efficiency on eBay using machine learning 10 years ago. And I think I may have been the first one in the industry to pioneer the use of structural SVMs in a search engine. And so we were able to take one of their the site, did a system called Shopping, a small part of the shopping engine that they had. Of course, the whole thing is a shopping engine. They had a particular site called shopping.com, which was a smaller version of eBay. And they would they would put eBay listings on the main, they would put shopping.com listings on the main eBay site. And what we wanted to do is show that we can improve the click-through rates on the shopping.com listings. And so we used an SVM to do this. And I was able to show that by doing this, we could increase the click-through efficiency by 15%. So you think about that for a minute, the scale at which eBay is at. Imagine being able to increase the number of clicks you get by 15% using machine learning. Now, at the time, nobody in the industry was doing this. I mean, I went and I gave a talk at Yahoo Research about this. The talk is online. I couldn't get the Yahoo guys through the first slide of the talk. It was an incredible, it was incredible. You could see why Yahoo, like what happened to them as a company. When you go and talk to their research team, you see what it was like. They were just not a healthy company. eBay was a very healthy company. Yeah, it's just a valley, companies come, companies go. Yahoo was once a big company. Now Google's a big company. It's just how it goes.
Right.
But we were at the time at eBay, we were the first ones to do this. We actually did the SVM, and then we built another system called RankNet, which was a neural network. So we had neural networks doing search relevance at eBay 10 years ago. And, the thing is that it was a very, very long project. I mean, that was a complicated project that required several PhDs and a lot of staff and a lot of time to do it. But it was possible because eBay had the resources and the scale. And they were using this technology for other things. For example, I had come out of a group that had built, I had designed I was a consultant and subject matter expert at eBay on machine learning. So we had started by building customer support tools using SVMs to classify their emails and route emails. And by showing that worked in customer support, we then said, well, let's try to do this in search. And it worked amazingly well in search as well. And then that eventually became Aardvark. I went and left eBay and I joined Aardvark, and having done, I didn't take it, I knew how all these algorithms worked, and knowing how all these algorithms work, we built Aardvark, and that got acquired by Google. And that was 10 years ago. So that was the kind of, to do that, making that work required being able to go through the academic literature, figure out what worked and what didn't, and then find some open source tool that you could productionalize. And that's how I did it. At that time, there was no Python code. Scikit-learn did not exist. There was obviously no TensorFlow. So you had to go to some academic lab. You had to download their code. You had to test it. This is basically running on the command line in Unix. And then you figure out, this thing seems to work. Why don't we see if we can productionalize it? Well, productionalizing command line code isn't so easy, but you can do it. You have to write, in Aardvark, for example, we write wrapper code around it in Ruby, and then eventually you can bind the code into Ruby using, some Ruby C libraries. And this is eventually what happened with Python, is that eventually the Ruby guys were just not up to doing machine learning and AI. It just wasn't in their DNA. They're smart guys, but it's not their thing. They were not mathematicians and scientists. So eventually it became, I said, doing this in Ruby is never going to work because it's just the culture. Ruby, as a language, Ruby is fine. The technology is fine. But as a culture, the Ruby culture, the Ruby on Rails culture would never support this. And of course, Ruby is now no longer the dominant language. Now Python is. And what happened was that eventually all these old academic codes got ported into Python. And if you go to scikit-learn and you look inside the guts of what the SVM code is doing, it's the same code I used at eBay. But back then, we had to, so it's, it eventually ended up as a Python to C level call, and the libraries are now integrated in. But the key to doing this is that you have to go and find what are the researchers doing, what's really state of the art right now, but also what's accessible. What can you reasonably get into production in a reasonable amount of time? And that, today, I think it's as true today as it was back then, because now there's just a lot more stuff. Back then it was C code that you had to integrate into Ruby and Python. Today, it's a pre-trained neural network, or, you go on GitHub and you find some neural network that someone has written and you try to integrate it and test it on your data and see if you can get it working. So I think the key now is there's just so much more. There's just so many more options and so many more problems that you can solve.
Yeah, any other examples of maybe one more example of a problem you solved that was really interesting to you, and then maybe one that you're wrestling with right now that you think is going to be pretty difficult, but may have a breakthrough in the near future that you're excited about?
Well, the big problem, the one I sort of got a lot of credit for, was demand media. And demand media is the first $1 billion IPO since Google. And this was the real magic of how you could use this machine learning technology, is that we essentially figured out a way to predict traffic on Google. So I don't know if you remember a site called eHow.com. It used to be a pretty popular
site. I
site.
remember eHow.
Now, yeah, eHow was very big. How did eHow get so big? Now, how did eHow get so much traffic? Well, it got so much traffic because we were able to figure out what articles to write and how much traffic they would get and how many clicks they would get before we wrote them. So we had a title. It was a very famous. Well, it was famous back then. 2010, there was an article in Wired magazine called "The Answer Factory," and there described this algorithm that Demand Media put together, where they could create titles. They have there was a patent, a Demand Media patent on this, where they would create titles, and these titles could then be from the title you could predict how much traffic you would get on Google, and from there you could predict your revenue. And that allowed them to amortize their content. So in other words, from an accounting perspective, something that typically looks like an expense, paying someone to write content, becomes an asset because it has long-term value.
That's amazing.
And
how accurate was the prediction, by the way?
Well, we were able to increase revenue by 500% and become $1 billion IPO. It was amazingly accurate. It worked perfectly, in terms of, and of course, what happened is that Google went. Of course, this totally freaked Google out. And I have the story I talk about. They don't like to talk. I claim, look, Google changed CEOs.
Well, if they did it themselves, that's okay. But if someone else does it, then that's bad. It's like, it's like counting cards at the casino.
Well, of course, that's exactly what we did. And Google changed CEOs, and after they changed CEOs, they introduced Panda. And Panda and Penguin were the big changes, and so the machine learning was essentially responsible for that. So, we all, at the time, it was great at the time. And it was a huge success. Now, I have my own, I would have done it strategically a little different. I would have grown a little slower. There are these problems with the startup when there's grow at all costs. And, it turns out that Google, they never imagined that Google would turn them off. Well, why would Google turn us off? We're generating all this AdSense revenue for them. Well, yeah, but you're also in 7 of 10. Your results are in 7 of 10 of every Google's long tail searches. That you've basically taken over the entire search engine. So that was a huge deal back in 2011 or so, and that was one of the biggest successes we had to show that this technology really works. You can really do this. Yeah, and that was pre-AI. That was just using vanilla machine learning. So today, using natural language processing, the technology is far more sophisticated. You can do all sorts of things. And we have a client now. Right. I have a client I've been working with, and it's been challenging. I won't say who they are. It's challenging to get them to move to AI. The CTO wants. So this is now the other side of the equation. Where does it get hard? It gets hard when you're in a large organization. Your CTO wants to do it. Company wants. He wants to do AI. We know him very well. But you have your field commanders. Big company isn't run by the CTO. He has to delegate to VPs. And project managers. And the problem you have in doing anything that's new and innovative, because remember, Demand Media was a startup. It was a startup. Any big company trying to do something new, you realize that you're trying to make project. You have to propose a project, and it has to be. So you have to approve a project, and it has to be available for your budget. So people inside the organization have to want to do this. And the problem is, whenever you propose something new, it's not obvious. It seems crazy. When people say to you, that's a crazy idea, or you're crazy, what they're saying to you is that, well, that just isn't obvious to me. Why would we do that? That's not obvious. And they won't do it.
Well, it's not only that, it's the politics inside of organizations. So if, let's say you have two departments, and you're approaching one department and wanting to do this AI thing, I could feel threatened. Like, what if this thing succeeds and they blow us out of the water? We're going to be in trouble and lose our jobs because all of a sudden they'll be like the darling of the company. will be the also ran. So I bet you that there's a lot going on. The deep sixes.
We've had that problem too as a consultant. And we had a problem with one of our large clients where one of the PMs in the company was basically saying that we don't know what we're doing, and he wants to come in and wants to, we need to do it this way and not that way. And my answer, I tried to explain to this guy, guys, we're consultants. Our job is to support you. Our job is to help you. It's not our job to compete with you. We're going to build this project. We're going to build this product, and then we're going to go away. And we're going to work on another product with another company. We're not threatening you. We're trying to help you. So people have a goofy understanding. They don't see it that way. Our job as a consultant is to help everyone be a winner. We want everyone to succeed. We want all of our clients to succeed, and we want everyone inside the organization to look like a hero. We have no vested interest other than just doing a good job. But even at that level, there are people who just are not able to make that transition. They have this, they're pathologically competitive in a way that is damaging to their own company. Because they have. But the real challenge, I think, is, that happens, and when that happens, those are just things that happen everywhere in society. Every group has those guys in it. There's always somebody in the group But I think more challenging is just that people, they just don't see it. They don't want to take the risk. And those are all challenges that big companies have, and we try to come in at a very senior level and try to manage that. Of course, it's not at all easy, and it's a good reason why Silicon Valley exists. There's no technical reason why. It's not a money reason that companies can't innovate. It's like it's much more personal and human than I think it is technical.
So right now, what do you think is possible with AI, and what's fantasy? And then the same answer 5 years from now.
So, as I said, what's possible with AI versus what's possible with people in organizations? I mean, there's a lot we can do with AI. I have a client now. If I were running things, so to say, we could probably eliminate 2/3 of the staff with what they're doing. There's this thing called robotic process automation. And the idea that there are all these people working in white-collar jobs that really aren't doing creative, innovative work. They're doing repetitive work, which probably could be automated to, even if you could automate 50% of it, that would eliminate half the jobs. And I think that the main barrier to that is exactly what you said. It's the human the humans that are stopping this from happening. But it will happen. Whether it will either happen inside companies or new companies will form with lower margins. Because if I only have 100 staff and you have 1,000, I'm going to kill you. There's no way you can defend against me because my margins are so much lower. You're going to die. It may take me 10 years, but eventually you're going to die. So I think we're going to see a lot of companies that rely exclusively on repetitive white-collar labor. I think those companies are going to die. Now, will it take 5 years? Maybe 10. Okay. 5 years from now, it's hard to predict the future. I would say that. I think that's where we're going to be 5 years from now, is a lot of these white-collar jobs are going to be severely threatened. And that's across the board: accounting, legal, research, things like this.
Right.
Because what we're seeing now in terms of how natural language processing is evolving, we've already seen it in object detection. But the way natural language processing is evolving, we're going to see huge changes. So I think we're going to see a huge disruption in the industry, to the way in which Amazon has disrupted the entire retail industry.
Right. Well, very good. Last item I wanted to ask you, because we're kind of running out of time. Who or what makes a good client for you? And if you can give some characteristics, and then how do those kind of people get in touch with you if they're listening? Sure.
We had a great client in Eastern Europe last year. Interesting group of guys they have a big company, kind of like the GoDaddy of Europe, and they knew that they had to become an AI company. They said, we know we have to do this. So they were taking classes at the Fast AI group here in San Francisco, all these free online classes. They had staff, and what they were working on are experimental projects. What kind of things can we do with AI right now that we can take existing technology and build products and get them to our customers? In this case, for example, they knew how to market really, really well to teenagers. So they wanted to make products like, can we make a cartoon caricature? Can we take a picture and turn it into a caricature? That would be the kind of product a teenager would buy. Or there's a product at Facebook where you take a video of yourself and you colorize the hair. And so now you can talk to someone, but while you're talking to them on video chat, you have blue hair. Those are great. Those are AI products. And they wanted to investigate those products. They wanted to try to build them. They had a staff engineer who was working, and we worked very closely together. And it was all remote. We just talked on Slack and on Zoom, once a week. We talk on Slack every day, and we'd have a meeting on Zoom once a week. And that was a great client because I think that they learned a lot about how AI works, what's doable and what isn't, because they were willing to just jump in and get their feet wet. And they had the right mindset that we want to take existing research and turn it into products. And they understood how to do that. And we were able to help them understand, how to really do it. What does it really take to do it? How do you evaluate it? What does it really mean? And it was a successful engagement. I think everybody was happy at the end of it. So those are the kind of clients that are the best. Companies that understand we need to become AI companies. We know that we have to build products, and we know that we have to, and we just can't keep building products the same way we've been building them. So we want to try to build new kind of products. We want to take research and turn it into development. And we're looking for someone to help us do that. And we're going to engage with them. We're not just going to give you some data and hand it off to you and tell you to build something. We're going to work with you and engage with you. And we're going to, really try to do this. And those are the best kind of clients. And they can reach us, send us an email, charles@calculationconsulting.com. As I say, it's kind of like the old adage, talk to Chuck. Just send charles@calculationconsulting.com. Send me an email, and we can get started.
Well, very good. Charles, I see you're super passionate about this and knowledgeable, and I really appreciate you coming on the podcast.
Hey, I appreciate you. I've spent my whole life in this space, and it's just a really exciting time to be able to help people really take advantage of it, and that's all we want to do, and that's what we're 100% focused on. So we really appreciate the time. And
you have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.